In this video we're going to look at basic matrix operations. So in the current video we are going to look at addition, and we are going to explain what multiplication of matrices means. And then in next videos we will explain how to do multiplication and more operations such as the transpose and the Hermitian conjugate. But let's start with addition of matrices. So matrices can be added only when they have the same size. And the way to add two matrices is you simply add the corresponding elements. For example, if you want to add the matrix 1a 0 2 plus the matrix 0 pi a and 1, let me redraw this parenthesis. So to add these two, you just have to add the first element with the first element, which is 1 plus 0 is 1. Then you add second element to second element, a plus pi, and so on, 0 plus a, and 2 plus 1, 3. And that's how we add matrices. Now, much more interesting and useful is how to multiply matrices, okay? So let's remember the fact that a matrix is a linear transformation of a vector. So you have a vector v, and you apply a transformation on it, and the result is a vector w, which is equal to a times v, okay? Also remember that the size of the matrix, which is in general m rows and n columns, so you always say the rows first and the columns second, yeah? So when a matrix has m rows and n columns, this means that this matrix is converting an n-dimensional vector into an m-dimensional vector, okay? So n-dimensional vector is being converted by matrix A into a m-dimensional vector, when matrix A is m times n. Why is this? Well, if you think it through with an example, it's actually pretty simple. So let's say you have a matrix that has 3 rows and 2 columns, maybe this one, this matrix here. So what size of vector does this matrix have to multiply times? So you can only multiply this times a vector that has 2 elements in the column, okay? Because if it had 3 elements, you wouldn't be able to do the multiplication. So for example, we multiply this by a vector 2, 3. And what is the result of this multiplication? So it would be 2 times 1 plus 0 times 3, that's 2. And 2 times 0 plus 1 times 3, that's 3. And then finally you would have 2 times 0 plus 3 times 1, which is 3. So the result is a 3-dimensional vector. So notice that indeed a times v equals w, and v is a 2-dimensional vector, while w is a 3-dimensional vector. And that is because matrix A has 3 rows times 2 columns. That's the size. Okay? So if you remember these basic facts, you are now ready to interpret what matrix multiplication is. So matrix multiplication basically is concatenation of linear transformations, okay? So let me walk you through this. Let's say we have a vector v, and we apply a transformation A, which is our matrix A, okay? So the output of this vector, of this transformation, this will be A times v, which we might call equal to w, okay? That is the output. But next, let's imagine that this output w, I put it into another transformation. So this, I put it into a transformation represented by a matrix B, okay? What is the output of this transformation? It will be B times W, right? But W is equal to A times V. Therefore, the output of this concatenation is B times A times V, okay? Now, here we just concatenated two linear transformations, but what if we interpret this whole operation of A followed by B? We might as well interpret it as a single operation, right? We can draw a black box around this and say that this is actually an operation C, okay? So we have this linear operation C such that we have the input vector V, we apply this operation C, and the output is our output vector. So we can write this output vector as C multiplied times V, right? Because this is basically now like a matrix multiplying a vector, which is the input, and the output is C times V. So therefore, comparing this with this, you can conclude that this matrix C that represents the concatenation of the two linear operations is given by the product of matrix B times matrix A. Okay? So this means that multiplying two matrices together, B times A, is what it really means is that you first apply the transformation associated to A, and then you apply the transformation associated to B. So be careful because we have to move from right to left. Yeah? This should resemble the fact that when you have concatenation of functions, for example, a function h of x is the function g of the function f of x. Yeah? You remember this. This is one function inside of another. So here you are also going from right to left. So you start with x, you apply function f, and then to the result you apply function g. Yeah, that's why we have those brackets here. So that's the way that matrix multiplication is always written. Let's call it the convention is that when you multiply two matrices together, it means that you are first multiplying A, and then to the result of that you are applying the transformation B. Okay? So that is the meaning of multiplication of two matrices. It's basically the concatenation of linear transformations. Thanks for watching.